So as we talked about in the last video, infinitesimals themselves are really close to zero. They're all squeezed in close to zero. And then other hyperreals, we have 10, then we could add an infinitesimal to it. And if we add one, it'll be a little bit bigger. If we subtract one, it'll be a little bit smaller. And so if I zoomed in with my microscope, I would see 10 as well as around it 10 plus epsilon, all these other hyperreals. Now, we can, as we just have seen, we can take a real number and add an infinitesimal to it, and we can see how it's ordered. We can take an infinitesimal and multiply it by a real number. But what happens if I take an infinitesimal and divide by itself, or I look at its reciprocal? Well, if I take something that's infinitesimally small and look at its reciprocal is going to have to be infinitely large. So coming over here, that's where the reciprocals live. So this is the infinite land. So that's why I've got dot, 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 because the real line never stops. But now we're introducing into the hyperreals the idea of an infinite number. So once we get past all the real numbers, and I say that in big air quotes because you can't get past the real numbers, but imagine we could. We'd be in the land of the infinite. And so over here, say, this is an infinite land, and if I were to, again, take my, well, now it wouldn't be a microscope, it would be an infinite telescope, because I've got to look all the way out into infinity, past the edge of the universe, if you will. Then, well, we see the line, and over here, say, would be 1 divided by epsilon. So if epsilon is really close to 0, infinitesimally close to 0, then its reciprocal is going to be infinitely far away from 0. So over here in the infinite portion of the line, we'd have 1 over epsilon, but then I could add 1 to this infinite number. So 1 over epsilon plus 1 is over here. I could subtract 1 over epsilon minus 1. So you may play games, with your friends where like, oh, I'm a better skateboarder. Well, I'm infinitely better. And then of course you would say, well, I'm infinitely plus 1. But so if anybody was kind of listening to your conversation, maybe they would have told you you can't add 1 to infinity. Well, I'm here to tell you contrary. In hyperreals, we can add 1 to infinite. So we've got an infinite number, infinitely large. It's bigger than everything else. But I could add 1 to it, and that has to be a little bit bigger than 1 over epsilon. Or I could subtract 1 and get smaller. And then down here to the left, we have, and if I were to pull out my infinite telescope and looked way out here, then I could look at the reciprocal of -1. So I would have a negative infinite number. So we've got still the infinite number line, and we would have -1 over epsilon. And again, we could add 1 to it or subtract 1. It has the same behavior. Oops. Yep. So now we have a model, if you will, of what the hyperreal number system looks like. It looks just like the real line that we're used to, but now we can zoom way in and see our infinitesimals. They live here. Or we could use our telescope and zoom way out and look at the infinite numbers. But they're going to have a lot of the orders that we're accustomed to, a lot of the behavior that we're accustomed to with real numbers. A lot of the algebra is going to work out just like it did before. But that is kind of leading into the next section. So 1.5, which is what we'll talk about next, is how do we do algebra with infinitesimals? How, if I have a hyperreal, how can I determine, is it a finite number? Is it an infinitesimal number? Is it an infinite number? And if it's infinite, is it positive or negative? So those are questions that we'll bring up in the next section.